Rich asked me just to come and talk about meta-virtualization, OpenEmbedded in general. I maintain meta-virtualization as well as the Yocto kernel, a cloud services layer, and as well as some real-time layers in Yocto. And so I work for Wind River, and I'm going to talk about those layers in general in the upstream in OpenEmbedded, and then a little bit about how we use them at Wind River to build commercial products on top of Yocto and OpenEmbedded. So there we go. The one thing I always like to say is we always have this, especially at Wind River, because we're an embedded Linux company. But we use OE and Yocto to build platforms for anything from tiny little gateways and ARM boxes to the biggest class of Xeon server you can buy. So what we always say is you try to get pigeonholed into embedded or enterprise, and so there's a continuum that we find, and a lot of time it comes down to the ability to tune and tweak the Linux that you're running, and it might be easier if you start from an embedded base like OE versus trying to tear down an enterprise distro like Red Hat or SUSE or any of the others. So the big thing, if you don't know about OpenEmbedded, it includes a cross build environment. You have to do all of your own configuration, but it works directly with the upstream sources. So it takes care of fetching the packages, doing the configuration, cross-building them, and it's designed to be extended by layers and expanded for your own uses. So that's inherently part of the design of the system. And if you use OpenEmbedded, you can get both community and commercial support, and I sit on both sides of that on that line. So then the question is some people tend to OE has been around for a lot longer, OE Classic and the way it was, but about 2012, the Yocto project popped up, and this, I guess, it confuses some people. What's the difference between OE and Yocto? And well, really, Yocto is just some structure that was put around OE and some of the core packages and recipes in OE to make sure that it was more stable, more buildable, and something that was they could add features to like that are important for commercial support, like reproducible builds, the ability, some tooling around it, and different things like that. So it's Yocto is an umbrella project that provides that ecosystem around OpenEmbedded, if you will.
Similar to Fedora and Red Hat?
Different, still. Yeah, you would almost say like Yocto to Wind River is Fedora to Red Hat. Yeah, or Monte Vista or Enea or anybody who builds a commercial distro on top of OpenEmbedded in Yocto. So I guess it'd be more like the OpenStack Foundation. It's sort of an umbrella where there's projects underneath it. And so there you go, that's just what we said. So it had a big part about when it was founded with the Linux Foundation, Intel and Wind River, TI and a bunch of other founding members. There's some structure, so there's an advisory board and there's technical leadership, and that way the project can do things like have defined 6-month releases with planning and community managers, and it's a more predictable cadence for somebody who wants to build product on top of OpenEmbedded. All right, so we put a bit of thing in here because there's obviously many different ways to build a Linux distro, and it all depends, or an image. It depends on what you need out of that image. So there's a lot of different options. Right? So what we have for embedded Linux requirements is that we want to build on an existing Linux ecosystem. You want to build a complete system that's customized for your specific device. That includes bootloaders, the Linux kernel, the different root file systems. You need to be able to build from scratch, but that means you need to have reproducibility. When I build my image, somebody else should be able to build the exact same image and should be able to prove is the exact same image. And that's something that actually has been multi-years of work within OpenEmbedded to get better on that front. A big one, IP compliance is actually a big deal. Like you see some of the, if you go to Docker Hub or you pull down some VMs and they say built from Alpine Linux or built from Fedora, that's great, but if you actually don't have a path back to the licensing and the IP of all of those packages, you're exposing yourself, and actually it's very difficult to ship it commercially. So that's a big thing. So what I'm going to talk about a little bit when I get more into meta-virtualization is that is one of the advantages we would say about OpenEmbedded. Even if you're not using it to build your to build Zen or Docker, run it with containers. If you're building VM images, guests, containers, that if you can build it from OpenEmbedded, you actually have that path back to IP compliance and licensing, and that's important because you have a much easier route to ship your containers and your VMs, make them available in binary form, but have that backed by the source and all the licensing that you need. So those are sort of, that's the rundown of, say, what Wind River was doing by ourselves, Monte Vista, everybody was doing by themselves. This is what we need. So, the alternatives in that, we had our own at Wind River. We made a huge switch from build systems when Yocto started. So there's, OpenEmbedded. There's different enterprise Linuxes with their IoT variants now. Everybody's got, there's Snappy Core and Core OS and all of the sort of IoT type variants. You can use build root. You can roll your own. There's Linux from scratch. We could go on and on and on. There's so many different ways to build a small, embedded type of Linux. So, that's what I was saying about, enterprise Linux. It's got a very easy entry level. It's you can use it for prototyping because anybody can download it, boot it, try it out. But if you customize it, how do you do it? How do you get it supported when it's been customized? How are you going to maintain it? Those sort of things come in when you decide to ship on top of an enterprise Linux. Build root is very popular. It's a very simple entry point into embedded Linux. Has limited build extension points. It doesn't do binary packages. And there's a lot of forks that end up being created of it. But it's absolutely suitable for a lot of use cases. Roll your own. It all depends on who decided to start rolling that distro, what they chose. They're usually completely custom, and it usually turns into a bit of a support and maintenance issue. So with all those alternatives, we always say, why OpenEmbedded? In full disclosure, OE might not be right for all your situations. Do you have a PC-like usage model? In that case, enterprise Linux or variants might be better, right? Is it a one-time board bring-up? OE might be too complex. Maybe that's build root. But if you have a footprint, if you want to do a lot of customizations, you want to work on the footprint, boot time, all of those fine-tunings, optimizations, you need long-term maintenance, you want a commercial ecosystem, IP compliance, then OpenEmbedded and Yocto is probably what you want. Because as we always say, we go to embedded Linux conferences, and the last thing we need is, they say the last thing they need is yet another open source license, and the last thing we probably need is yet another embedded Linux build system. So the big thing about OE and Yocto is that the base and the core of the system is extended by layers. So layers are a way to manage the extensions, customizations to the base, and keep it separate so you can maintain it by yourself. So you can add, extend, replace, modify recipes. You can change class files, which actually are the build system itself. You can modify configs, and you just add them by a simple configuration file. There's some ongoing work in the community to move some recipes around and reorganize, and it's a continual process to get the best organization of the layers. But best practices, the layers are grouped by functionality. There's distribution, so there's a Wind River layer where we have our distribution. There's BSP machine layers if a vendor is doing a BSP. There's functional groups, that would be meta-virtualization, where we have, well, I'll go into that in more detail, but meta real-time and all of meta OpenEmbedded, there's these different groupings of recipes. And I actually, myself, prefer these functional groups rather than grouping it really, really generically, because if we group like functionality, it's easier to test because we actually have a system-level use case rather than saying the package compiles, it must work. Right? That's sort of step zero. You need to go farther. So that's how you view layers. They're just, when you put them into your configuration, they're just buckets of Lego. It's up to you and how you configuration your images, and your end configuration is how they get put together to build things. And so typically, you have something like this. It's a stack of layers. So you have OE core, Well, actually not meta-Yocto anymore. This slide's a little bit older. You probably don't have meta-Yocto in there, but you have a hardware. You have your BSP, whether it be your own, came from your board vendor. You have some of your, whatever your images are going to be that the user's going to see. Then potentially you have a commercial layer from OSV and then your own development layer. So it's a big stack of layers and they all work together to build the final image. The broader OE ecosystem, you would say, when you hear us talk about that, it's all the layers and projects that are out there. And you can find them all on, I had a link, I see it didn't make it in this, but it's easy. There's layers.openembedded.org. And on there you can see everybody's layer, everybody's recipe, what inherits what and how they work. So, you know, if you have a layer, please register it with layers.openembedded.org so other people can see it and not. We have multiple things. In fact, security is, the security related layers is one of the things that we're trying to consolidate and factor out for the fall release this year because there's multiple. So you'll end up with 7 grub recipes and everybody didn't either know or had something and they didn't work together. So that's something that we try to avoid. But if they're published, then people will know, at least they won't start their own. And there are tools to support testing compatibility because there's rules around layers. Like a layer should not modify your board's configuration. So you should be able to add my layer and it won't change your BSP's configuration, it won't change your kernel's configuration, it won't break anything in your images just by being there. We'll skip this. This is the OE architecture and how the build system works. It'll be in the slides if anybody wants to. So the other thing that I wanted to talk about was, you know, how and why is Wind River using the Yocto project. That's what I was saying, you know, basically prior to the Yocto project, there was a lot of different commercial Linux products. They were all incompatible. We were spending all of our time writing recipes for core utils and, you know, all the boring stuff, Flex and Grub and Bison and all the stuff that everybody was doing. So, you know, but that's not where the value is added by commercial Linux. It's not where anybody's value is added. So, you know, it was, in order to do that, we had to either work together, and also our customers were more and more being unwilling to be locked in to a particular vendor. So they needed that compatibility. So that's why Wind River and multiple other embedded Linux vendors work together on. So we knowingly are all using a build system that allows our customers to switch between the vendors. But that allows us more time to do our innovation and differentiation because, you know, Linux is the commodity. Nobody's going to buy you because your kernel is slightly different. You know, I've actually spent a lot of time at Wind River doing our kernel with real-time extensions, and I did real-time KVM and these different things. But even that's a window of like a year. But nobody's going to buy you because the stuff is different. It's all about, you know, what features you support, what kind of like deeper stacks that you can put on top of the OS. So there's no sense maintaining that base part. So we don't want to maintain it by ourselves anymore. We do a lot of work directly in Yocto and OE, but we don't do it in our own trees. You know, and that allows us. So what we provide is, you know, and everybody else is software lifecycle management. So if you want to consume OE directly, you have different maintenance windows. You have 2 releases a year. In fact, it might be too fast. So, but knowing that there's this cadence of OpenEmbedded, then we can have our commercial product lifecycle varying on top of that. So we manage the pace of stability as well as integrating the pace of change from the upstream. So that's what we use OpenEmbedded and Yocto for. So what that looks like inside Wind River is we have a core product which is closely based on OE core. We have a set of selected and curated layers where we add our own image types and our own distribution on top. And it also allows us to produce, as in the last year, basically all of Wind River's work for Wind River Linux is available on GitHub through an open source community. So you can pull everything that we build internally is available on GitHub. What that does is allows us to set up our own CI/CD stream both internally and on GitHub. So we're always tracking the very tip of OE core and Yocto, and allows us to let our customers see that stream, or anybody who wants it. On top of that base, we have our own Wind River BSPs where we work with the different silicon vendors to produce BSPs and integrate them and support them. And in fact, lately we've been trying to push even our BSPs to the Linux Yocto kernel, which is the kernel that I maintain in OE core, to make them not even available only in our tree, just to make them more widely available, because a whole bunch of evil vendor tree kernels is not really helpful to everybody either, because you can get drastically different behavior based on different kernel versions. How do you support it? What happens when the next Spectre and Meltdown comes out? Is your kernel patched? If we can consolidate the number of different kernels and versions to a discrete number at least, it makes everybody's life easier. And then finally, on top of that, what it looks like to us at Wind River is we have these vertical specific products or distributions. So we have one for networking, industrial. We have technology horizontals, which is virtualizations, containers, and security. So it's sort of, again, it's that picture I showed of the layers, but in a commercial context. So I don't know how fast I was through there, but that was the blindingly fast summary to make up some time. So now I'm going to talk about meta-virtualization, which is what I was really here to talk about. So if you go to OpenHub and look at the statistics on the project, it says it's mainly in shell script, but that's because it only looks at the build system part of it. But it's been around for a while. I've been a maintainer since pretty much the very beginning of it as well. But we have 104 unique contributors over the years, which is actually pretty good considering that this is just a very specific thing on top of OE core. We started it in 2012, and the contributors they're actually getting broader over time. A lot of the OSVs, Wind River, Mentor, Monte Vista, Enea, they've all put things into it, as well as a lot of different individual users. And it's sort of like the Linux Yocto kernel. We don't hear from a lot of the users, but I go to a conference and everybody says they're using at least some part of meta-virtualization. So I assume they're happy users, or they're just swearing in forums that we don't see. So the goal of meta-virtualization, it's sort of a single point of integration for virtualization technologies. Now, I toyed with renaming the layer, but once you have mind share with your name, there's no sense messing with it, because if you consider containers system OS level virtualization or separation, so as meta-virtualization is also where all of our work on containers happens as well. So we have virtual machines and containers. It has the core technology as well as software that supports virtualization. It has many different audiences, so we try to follow the bleeding edge of a lot of these projects, as well as keeping the established technology available in the layer. So that would be my example of that would be, we have KVM and Zen, but we also have Docker, Moby, and Kubernetes, sort of the bleeding edge and blending. And we have RunV in there, which is an OCI interface to virtual machines that look like containers. Right? So there's both. So you have a migration path. And we want it to be a baseline for creating OpenEmbedded derived virtualization solutions. I have a note there that recipes migrate over time. So as things maybe get pulled into OE core, or they make more sense in one of the more generic layers, we've moved a few recipes out over time. So you'll see the number and the size of the layer bouncing over time. So there you go. I won't read this, but yeah, it's got a little bit of everything. It's got images for guests and hosts, containers management, the utilities, their support configurations, kernel configs. So the big things, if you need to do container work, like I was mentioning, if you want to build a IP licensed lightweight VM or container, well, we have what you need in meta-virtualization to do that. Everything from runC, if you want to use the core the Linux Foundation container OCI runtime rather than using Docker, you can use runC. We have LXC still, containerd, Kubernetes. I mentioned we have RunV, which will become Kata containers because Huawei and Intel took Clear Linux or Clear containers and RunV and made Kata containers. But we're sort of watching that to see where it goes so I can finish the integration. But then we have what you need to manage it, libvirt, Open vSwitch, different networking hooks, things like that. Everything's in there. CNI, if you need to do, use those plugins for Kubernetes, a little bit of everything. the use cases that we tend to support and I test with the cycles that I have is virtualization, of course, use cases, whether it be Zen, KVM, hopefully more hypervisors in the future as they pop up and become relevant. So in that way we can tune them to be small, secure, whatever you need to do to them versus a generic build. There's a lot of now containers use cases, whether it be microservices, serverless, that sort of thing, or standards-based containers with the Open Container Initiative runtime. And the big thing I always say is that the VMs and container coexistence, the peaceful coexistence, there's no reason why either they're both running as first-class citizens on some of our images, or you're running our containers inside of VMs, you're running VMs inside of containers, or whatever you want. It's all in one place because they all tend to be used. There's no reason why you can't be doing microservices inside of your VM running on this container runtime. We use, inside Wind River, what we do with meta-virtualization is we do our core hypervisor support, which admittedly is mostly KVM and not as much Zen, but you never know over time. We do our core guest and host support, but we have real-time and security variants that we layer on top of that. And we do a lot of container work lately, which is Docker, LXC, Run C. And we've built an entire OE-based container OS called Oversee, where I spend a lot of my time. And I won't bore you. That's a whole different presentation on a container OS built on top of OE. So to put that little bit of spin, I just wanted to sort of start wrapping up with a little bit of how Wind River sees our security horizontal requirements on top of meta-virtualization and our virtualized solutions. So we do have multiple different types of secure boot offerings, and our goal is the same as everybody else's, is to maintain as little as possible as BSP specific and leverage hardware where possible. So, and avoiding one-offs. So we end up having to build solutions for specific customers, and over time and some of the work we're doing upstream, we're trying to get that factored out to make at least the customizations to be more standard, so we do less one-off work to produce these secure systems. We do have multiple layers of security, so whether it be from the secure boot through the TPM, IMA, containers for separations, VM. So there's multiple different layers of security that have to be able to be layered on top depending on the requirements of the project. And we do work multi-architecture, so we need to support it across x86 and ARM for the most part. Oh, I see my little boxes. So this is just sort of that broad, this is the spectrum of virtualization and security and how we layer them together to build our various products on top of that. And you'll see that in our efforts up in OpenEmbedded and Yocto. And what that looks like, and actually this is a little bit of the container OS that I was talking about, that we take those parts and those layers in that security horizontal landscape that you'll see, and we'll build these reference images that work out of the box on various platforms that are extendable. And one that I spent a lot of my time on is this Oversee, which is a containerized OS, and it takes those same parts. It's referenced based on OpenEmbedded, our layers. It builds a binary sort of a binary image, has this kernel that's got some real time and some security modifications to it, does a segmented user space that can run VMs and containers and integrate with Kubernetes and all of these things. So that's what the final output that a lot of our users see with something like this is these reference images. So that's how it builds all the way up from the OpenEmbedded community through what we do at Wind River with our CI loops and our different community projects, with our layers, our security requirements on top of it, and then this is sort of that end product. And there's no reason why any of these images, if somebody, they're all, of course, on GitHub and available, but this is the sort of thing that you can do with OpenEmbedded and Yocto, whether it's running in your guest of your VMs or even if it's in the hypervisor layer. And so finally, what the future may hold for meta-virtualization, new technology. I'm always trying to add new recipes and chase the new stuff. So maybe we'll be able to build some of the new hypervisors, Acorn, or more container and sandbox techniques, gvisor, Kata containers, pouches from Alibaba. Looking to get more and more improved system level use cases, like OpenXT is probably that's a big system level use case, right? It builds it all up, and that's more of the testing that we need, because my pet peeve is, it doesn't really actually mean very much that a package compiles. Does it work? Does it work? Is it configured properly to work with the rest of the system? And we have real system level use cases to test that it works, and that's lacking. So that would be sort of one of my things to try to add to meta-virtualization, is to have an easier out of the box system level use cases. Try to get more of the security toolkit and core components moved around properly. It will involve meta-virtualization a bit. And this is one thing that Richard Purdy has put out as one of the things he's looking at for the next release. Yeah, and that's it. I mean, really, and of course, one of the things we're always working on in OpenEmbedded in general is that developer experience. How easy it is to build your microservice, your VM, your host on top of OpenEmbedded. So building it, but then if you have a development team running in the background, there's a whole different 3-hour talk on how to enable development teams on top of OpenEmbedded with CI loops and all these things. So. But having the core layers enable those types of workflows is important, because if the first experience of building against an SDK or building an application is terrible, then you failed and you won't get used. And of course, we need more help. If anybody is using meta-virtualization and has patches they haven't sent, feel free. It's pretty much a flame-free mailing list. You can send whatever you want, and nobody will yell at you. That's it. If there's any questions, I don't know how long that took, but it was fast. Yep.
So you talked about embedded a lot, and even OpenEmbedded is in the name. If it's like an x86 image that you're trying to make, would you recommend against using OpenEmbedded?
No, like I say, it's not. If your requirements are what I was saying there, if you want to build from the source, you want those reproducible builds, you want extensible SDKs. There's a whole set of things. But yeah, we build giant server class images that run on the biggest Xeons that have desktops and Kubernetes and all of these things. It's just more of a point of view where this is building up versus taking an established enterprise distro and their security policies and update mechanism. If that's what you need, that's good, but you can totally build a very similar system up from OpenEmbedded.
Is there a wrong use case for OpenEmbedded to build like x86 images?
No, I mean, the big thing is, the difference is, and this has changed a bit. I mean, the set of packages, if you go look at, say, in Ubuntu, there's 22,000 because it's based on Debian, right? The 22,000 packages. There's not that many in OpenEmbedded, but a lot of those numbers, it's hard to compare because there's variants of packages, and you don't need 22,000. So the package list would be a little bit different, but with containers and Docker and stuff, I mean, we can pull and run anything off of Docker Hub. So all of that whole ecosystem is available on top of images that you've built from OpenEmbedded. Yep.
You mentioned testing, kind of. Are you doing testing of the Zen recipes for meta-virtualization?
I do my own builds. I think most of the testing probably comes from derived projects that we know are using meta-virtualization. And I actually really rely on the different teams that are submitting patches and uprevving and moving the Zen support forward over time. I really rely on them for a lot of the deep system level. That's my thing. I need these improved. I need system level use cases that I can build and run myself. Otherwise, I really am relying on other people, which isn't a bad thing, but that's sort of how that gets tested for the most part.
So that's a great question, and the way everyone here can help is by donating hardware to the Yocto Foundation, and then we can have work with them to run those test cases. So that's something we've talked to Yocto and OpenEmbedded about. Because if you want to do if people want to do hardware-assisted security, guess what? You're going to need some hardware. And that hardware changes every year. That means every year you've got to ship, all your upstream projects where you need them to work with them. They've got to participate in your CI loop across the ecosystem. And that's a big shift because people are not used to that. And so that means your employer has to put a budget aside every year. You got to ship that device. It's got to be racked. It's got to be tested. But it's a missing piece in the sort of cross-project, cross-community integration. So very, very important. And we're working with both Zen and OE to try and make that happen for the pieces of open systems. But all hardware-based security projects really need this.
You spent some time talking about the different layers and this kind of, the layer index and all these things. I was wondering if you could share some of your thoughts on the partitioning. What's the entry criteria for things that go into OE core? What are the things that need to stay in separate layers?
Yeah, I'll repeat the question because I'm mic'd. It's so what's the gist of it is what's the how do you figure out where a recipe goes? What's the partitioning, whether it goes to OE core or one of the functionality specific layers? And honestly, yeah, it's there's not a hard and fast set of rules. I know there's resistance actually for much new to get added to OE core in general. So really, if something is used by say 2 or 3 different layers, 2 or 3 different technology areas, multiple architectures, it's very a common set of functionality, it's becoming common, then that's a vote for it to go into OE core. But the reason that they push back on OE core is that it has limited test loop and hardware. As soon as they add more packages, then somebody needs to be able to maintain it with the right cadence, because there's different, I think I had it in the slides, I didn't say it, that there's different quality metrics around each layer, and OE core tends to have the highest because that's where the Yocto project focuses. So that's sort of that's the criteria to get into OE core. But if they had more resources and more test hardware than build machines, then I'm sure more could go into there. And then if you have a recipe that's specific to an area of functionality, it's preferable to try to get it into one of the existing layers if there really is one that sort of does fit, because having too many layers is not a good thing either, because then nobody knows where to start, and then having too generic of layers is also a problem. And so it tends to be, if it's not in OE core, the first entry point people try is meta OpenEmbedded, which is that collection point of all the rest of the fairly common recipes that aren't very specific to, say, virtualization or security. They end up in OpenEmbedded. But yeah, I mean, it's hard. That's not easy when somebody's trying to figure out where they should submit their recipe. All right.